This is part 4 of the homework video guide for section 4.5, applications of linear relations. And let's start off this video with question number 10. For question number 10, Mel has two options when renting a car. So the first option is $45 per day and no charge per kilometer, and option B is $36 per day and 12 cents per kilometer. Okay, so I have gone ahead and I have labeled my graph at the bottom here because for part A, I need to graph rental options A and B. So I have cost on my y-axis and I have kilometers or distance on my x-axis. Okay, so what we're going to do next is, before we start graphing, let's go ahead and create a table of values for both option A and option B. So option A, let's just create a table of values over here so that we can have an idea what the graph would look like. All right, so for option A, it's $45 per day and no charge per kilometer. Okay, so what does that mean? So if I drive 0 kilometers, so if my distance is 0 kilometers, I still have to pay $45. If I drive 1 kilometer, I still need to pay $45. And if I drive 2 kilometers, it's still $45. In fact, if I go up to 100 kilometers, I still have to pay $45, right? So regardless of the distance, regardless of this distance, I still have to pay $45. Okay. So since my y values, since my 45, so sorry, here are my y values. The y values aren't changing, right? So this will look like a horizontal line eventually. So let's go ahead and graph this slowly here. So my first point is 0, 45, so that's about here, right? And from there on, it's just going to be $45 for every kilometer, right? So the 45 is the y value here, and notice that's not changing, so it's just a straight horizontal line. Okay, so that's it for option A. So $45 per day. If I had to graph that, it's just a straight horizontal line of 45. Okay, and 45 is about right here. Okay. Now option B is a little harder to graph at the beginning, and I may not be able to finish my graph right away, but let's go ahead and collect some data for option B, and let's put that over here in this table of values. So it's $36 per day and 12 cents per kilometer. Okay, so what that means is if I drive 0 kilometers, all right, so to start off, I drive 0 kilometers, I still need to pay $36. Okay, so maybe this is some kind of rental fee. Okay, if I drive 1 kilometer, I need to add another 12 cents. So now it's going to be $36.12. If I drive 2 kilometers, I need to go ahead and add another 12 cents. So this would be $36.24. If I drive 3 kilometers, this would be another 12 cents, and this would be 36, I believe. Okay, so that's my data initially for option B. Now, because if you look on my x-axis, I'm going up by like 50. I'm going up by 50 kilometers and 100 kilometers. Right now, I just have data for the first 3 kilometers, so I can't really finish off my graph. So what I'll do right now is I will just maybe plot this point here, 0, 36, and that's the y-intercept, so that's about here, right? So I just want to say that this point is roughly around there. And what I'll do now is I will come back to question A a little bit later on once I finish question B, and once I finish question B, I'll come back to question A and finish off the graph here, just because I don't have enough data points. Okay, so, but that's the initial start for this particular problem here. Okay, let's take a look at part B first, and once I finish part B, then I'll go back and finish off the graph for part A. How many kilometers must Mel travel to make option A the cheapest rate? Okay, so for option A, it's just $45, right? We're paying $45 the whole way, and this is just a horizontal line. I believe we were able to establish that in part A of the problem here. Now, when you have a horizontal line, in order to write the equation, it's just y equals to the y value, and the y value is just 45. So there's my equation for part A. Now for option B, I've written down that the slope is 12 cents. And that's because every kilometer you drive, every kilometer you go up by 1, you have to pay 12 additional cents, right? So it's 12 cents per kilometer driven, so that's your slope. Now, in the beginning, I believe option B is cheaper at the beginning. Why is it cheaper? Because at the beginning, if you drive 0 kilometers, you pay $36. If you drive 1 kilometer, you're paying $36.12. Whereas in option A, you're paying $45 at the start, right? So option B is cheaper at the beginning, but then it becomes expensive. So this question is asking how many kilometers can I drive under option B so that option A is the better buy. That's essentially what this question is asking for. Okay, so what we need to do now is I need to write an equation for option B. And anytime we're writing a linear equation, I can start off with y equals to mx plus b. And my slope here is going to be 12. So let's go ahead and plug that in. Sorry, not 12, but 12 cents. So y equals to 0.12x plus b. Now you need to figure out what is your y-intercept. And sometimes the y-intercept is called the starting value. Now if I go back to question A, for option B, the starting value, the y-intercept is right here at that green dot. It's at 36, right? So it's really this point right here, which I'm highlighting on the table right here, 0.36. All right, so what does that mean? It means my B value is going to be 36. All right, so now my equation is y equals to 0.12x plus 36. Okay, great. Now what I'll do next is, since I have two equations, I'm going to solve these two equations by using the substitution method here. And basically what I'm going to do here is, using the substitution method here, this y, and this y, I'm going to make those two y variables equal to each other. So if I do that, what I'm trying to say is y equals to y, and this first y is going to be 45. And this second y is going to be all of that. So this is going to be equal to 0.12x plus 36. And my goal is I want to solve for this x variable here. I can do that by subtracting 36 from both sides. And 45 minus 36, that is going to be, it's going to be about 9. And if I continue here, this will be 0.12x. And then I'll divide both sides by 0.12, divide that by 0.12. And if I do that on a calculator, 9 divided by 0.12 is about 75. All right, so 75 kilometers. Okay, so I'll probably be able to explain what the 75 kilometers means by going back to what that really means by going back to part A of the graph. Okay, so going back to part A now, let me just finish off this graph here. 75 kilometers was my answer for part B, right? So if I look at my horizontal axes, I have 50 kilometers, this is 60, this is 70, this is about 75 right here. So 75 here in orange. And if I go straight up, that's going to represent this dot right here. That's about 75. And now I can connect my graph here. And that's what my graph will look like for part A. Okay, so what does this really mean? What this really means is, for the first 75 kilometers, option B, which is highlighted in green, is cheaper than option A, which is in purple, right? So as long as you're below the purple line, option B is cheaper. However, after 75 kilometers, which is represented by this blue line, option B is actually more expensive, right? Whereas option A is a straight $45. So this 75 kilometers, which we just figured out algebraically in part B, we need to drive at least 75 kilometers so that option B is the cheapest option. After 75 kilometers, option A is now the cheaper option. Okay, so once again, we can drive up to 75 kilometers. And if we do that, then option B is cheaper than option A. And then after 75 kilometers, $45 is cheaper, right? So option A is cheaper after 75 kilometers. And that's what this answer really means for question B. Okay, So hopefully that answers that particular problem. And if I go back and read the problem, how many kilometers must a male travel to make option A the cheapest? Okay, so well, you have to drive more than 75 kilometers. Okay, great. Let's move on to question number 12 now, the last problem for this homework video guide. So section 4.5 is quite long. I think I have 4 videos to kind of solve all the problems. I go quite slow, and if you feel a little bit more confident, you can move a little bit faster than I am. For question number 12, when dresses sell for $80, 5 of them are sold each day, and when dresses are on sale for $40, then 13 dresses are sold each day. Okay, so for 10 dresses, for part A, for 10 dresses to be sold on a given day, what should the cost be per dress? Okay, so I have a table already constructed on the right here, so let's go ahead and fill in that table here. When dresses sell for $80, 5 of them are sold. Okay, so if I sell 5 dresses, the price is going to be $80. No problem. When dresses are on sale for $40, then 13 of them are sold. Okay, so I can sell 13 of them, and the cost would be $40. Okay, so part A is asking for if I sell 10 dresses. Okay, for 10 dresses. Okay, so what we're going to do is on my table of values here is right now I have 13. 13 of them will cost $40. If I go down by 12, 11, and then 10, this is what we're trying to find. If we sell 10 dresses, what will the price be? All right. Now, in order to do this, we're going to use the concept of a slope here to get down to our answer here. And we know the slope is rise over run, which is a difference in your y values divided by a difference in your x values. Okay, let me just erase this for now. All right, so as I said, the slope is a difference in the y values. So here's my difference in the y values. So that's going to be 40 minus 80 divided by a difference in your x values, which is right here. So that's going to be 13 minus 5. And if I go ahead and do that in my calculator, it's going to be negative 5. Okay, so negative $5. So negative 5 here. So how do I really translate that? So basically, as you can see, from 80 to 40, the price is going down, right? So the more dresses you sell, the price is going down, but the fewer dresses you have, the price should be going up. So if I go down to 12 dresses sold, if I want to go backwards now, I don't subtract 5, I'm going to add 5. So this is going to be $45. All right, and if I want to go to 11 dresses, I need to add another $5, which will be $50. And if I go to 10 now, I need to add another $5, and that's going to be $55. Okay, and hopefully that makes sense, right? So the fewer dresses you sell, the more expensive it should be. The more dresses you sell, the cheaper it will be. All right, so I guess the slope here, negative 5, means the more dresses you sell, the price should drop by $5. And if you sell fewer dresses, then the price is going up by $5. Okay, so I believe for part A, we're just looking for this part right here. So for 10 dresses, what should the cost be? Well, it's just $55. And the good thing is, since we have our table set up, part B will be a little bit easier. If dresses were $50 each, then how many would the store expect to sell? Okay, well, $50 is right here, right? So if it's $50, I guess we're selling 11 dresses. So this would be 11 dresses. Okay, and that's it for question number 12. So if you set up your table of values and just understand the concept of a slope and finish off constructing your table of values, then you can find the answers for letter A and B quite easily. All right, so that concludes this homework video guide.